Now let us see how a memory data will be searched in the cache memory. Now let us see, this is my CPU and this is my main memory. The computer system has a main memory, and of course we need to have a cache memory. This is the CPU, this is cache, and this is main memory. Spare, the shape is not good, fine. Okay, now the CPU has a direct connection to the main memory, and also CPU has another parallel connection to the cache memory. Okay, main memory is accessed directly by the CPU, as well as the cache memory also connected to and from the main memory. Now, initially when a CPU wants to access a data element, okay, the data element could be either an instruction or an operand, as you already know. Okay, now regardless of that, let us say CPU wants to search for a data element. Initially, the search will be made in the cache memory. That means whenever CPU want to access a data element, initially for that data element, cache will be searched. Okay, if cache has the data element, then the data element will be collected from the cache memory itself. Okay, if the cache doesn't have the data, CPU is directly going to access main memory. Okay, now stay focused. When cache has the data element, then the data element will be collected directly from the cache memory. If the cache doesn't have the data element, CPU is going to access main memory to get the data. Now let us say during cache doesn't have the data element, main memory will be accessed and CPU will access this data. At this time, the corresponding data element will also be transferred to the cache memory. Why? Because the data element which is accessed currently can also be accessed in the near future. This is the primary implementation logic of the cache memory. Okay. Now, this is how the cache will be accessed. When it comes to the secondary memory, the secondary memory is connected beyond the main memory, because secondary memory is only auxiliary device. Now, let us understand the hierarchy here. When CPU wants to access the data element, first for the data element will be searched in the cache. If it is not available, I will go to the main memory and I will directly access it from the main memory. Meanwhile, the corresponding data element will also be transferred to the cache for the future references. Okay, the element which is accessed currently might also be accessed in the near future. Okay, now let us see. The data element which is being searched is neither present in the cache memory nor present in the main memory. So at that time, what CPU does? Can CPU directly go to the secondary memory and search? No. You can clearly see that CPU, there is no direct connection between CPU and the secondary memory. Okay. Even though the data is not present in the main memory, CPU will not access secondary memory directly. Okay. Initially, if the data is not available in the main memory, the data element will get transferred from secondary memory to the main memory. Finally, the CPU is going to access any data element only from the main memory. That is the fundamental rule. CPU can never talk to the secondary memory directly. Okay. Now, why CPU can't talk to the secondary memory directly? Let us see. Let us see that. Let us consider that the cache memory will take 1 nanosecond, rather 1 clock cycle. Cache memory will take 1 clock cycle. I will say that clock cycle. In order to search for a data element, if the data element is present in the cache, then it will take 1 clock cycle to locate that data element into the cache memory. Okay, to access any element out of the cache memory, CPU just require 1 clock cycle. If the same data element, if it is not present in the cache, CPU will have to go to the main memory and access it. So main memory will take 7 clock cycles. 7 clock cycles to locate and get this data element. The data element will take 7 clock cycles to be located and fetched. Okay, so the access difference is 1 clock cycle is for the cache memory, 7 clock cycle is for the main memory. Now you can clearly see when cache doesn't have the data, the miss penalty will be 1 more clock cycle. You know what is miss? What is hit and miss? What is hit? If the cache has the data element, it's the hit. What is a miss? The data is not present in the cache. Data present in the cache. Data is not present in the cache. Data is not present in the cache. Okay. When there's a hit, CPU will directly read. When there's a miss, CPU will directly go to the main memory. Got me? Now, in order to access main memory for the data element, I do require 7 clock cycle. So the access difference is 7 and 1. Now the miss penalty will be whenever there is a miss in the cache memory, then the miss penalty will be total 8 clock cycle, because 1 clock cycle which is wasted at the cache memory will also be added to the total access time. So the total miss penalty will be 8 clock cycles. That is 8 clock cycles. That is the clock cycle which is wasted at the cache memory and the clock cycle that are required to access main memory. Altogether, 8 clock cycles which are treated to be as miss penalty to access the data from the main memory whenever there is a miss in the cache memory. Now let us see why we don't, rather why CPU doesn't access the secondary memory directly. You know that 1 clock cycle, all it takes is 1 clock cycle to access the data element from the cache. All it takes is 7 clock cycles to access the data element in the cache, in the main memory. Now the thing is, if you want to access the secondary memory for the same data element, if it is not present in the main memory, the data element may take 7,000 clock cycles. You can clearly see what a waste of the time it is. If the CPU has to access the secondary memory directly, in the case of a miss in the cache and the corresponding data is not present in the main memory, all it takes is 7,000 clock cycles. This is the reason why CPU will never communicate with the secondary memory directly. Even though the data is not present, CPU will wait at main memory. Meanwhile, let the data gets transferred from secondary memory to the main memory. Finally and eventually, CPU is going to read the data element only from the main memory. This is the fundamental rule. Okay.